Hello, happy people. This is Mr. Wilcox coming to you again from my kitchen table. Last week we were talking about taking the derivative using the product rule, so just bringing down the exponent out front and subtracting 1 from our exponent. Today we're going to up it a little with the chain rule. So here's what the chain rule is. I'm going to pause for a second so you can write this down in your notebook, and when you're done, hit play again. So what the chain rule allows us to do is if we have a polynomial to a power, instead of having to box that out several times or FOIL it several times, what we can do is we can use the chain rule. So the chain rule says to find the derivative of something like that, we're going to bring our exponent and multiply it out front still. And we're still going to subtract 1 from our exponent, and we're going to leave whatever our function inside our parentheses was the same. But now we're also going to multiply by what the exponent inside the parentheses is. So that will make a whole lot more sense when we get to the example. But first, I have those steps written down for you, so you can put those in your notebook. So I'm going to turn the video off quick so you can see everything. All right, so I'm going to pause for a second so you can write this in your notebook, and then we'll talk about it again. So again, to use the chain rule, we're going to pull our exponent down out front and multiply by anything in front of our parentheses. We're going to subtract 1 from our exponent, and we're going to keep our function inside the parentheses the same, and we're going to multiply by the derivative of what's inside the parentheses. So here's our example. F of x equals 3x plus the 5 to the 4. So instead of having to box this potentially 4 times, what we're going to do is we're going to use the chain rule. So the chain rule says I can, to find the derivative, I can bring my 4 down out front, keep what's in my parentheses exactly the same, subtract 1 from my power, so that'll now be 3, and then I'm also going to multiply by the exponent, by the derivative of what's inside. So the derivative of 3x plus 5, the derivative of 3x is 3. Don't know why I can't draw 3's on here right now. There we go. There we go. And the derivative of 5 is 0. So we're going to multiply that by 3. So we can multiply our 4 times our 3 together to get 12. And so we get 12 times 3x plus 5 to the third. Now your instinct may be, well, what should I distribute that 12 through? No, you cannot distribute the 12 through because of the cubed power here. Anytime you have anything to a power that's not 1, you cannot distribute through unless you box it or FOIL it all out. And we're not going to box or FOIL it all out. We are going to leave our answer like this. So our answer is actually 12 times 3x plus 5 to the third power. All right, I have one more example for you. So this example is g of x equals the square root of x squared plus 4x plus 3. This example actually is using the chain rule because we are taking x squared plus 4x plus 3 to a power. If you've forgotten how that works, I'm going to rewrite g of x as a power versus a radical. So x squared plus 4x plus 3. Remember, there's a hidden 2 when we take the square root. I can't write it 2. There we go, 2, and a hidden 1 outside. So the square root is really taking something to the 1 over 2 power or the 1/2 power. So I'm really taking x squared plus 4x plus 3 here to the 1/2 power. So to find the derivative, I can bring my 1/2 down out front, leave what's in the parentheses exactly the same, so x squared plus 4x plus 3. And if I subtract 1 from 1/2, I get negative 1/2. And I'm going to times it by the derivative of what's inside the parentheses. So the derivative of x squared is 2x to the first. The derivative of 4x is 4. And the derivative of 3 is 0. All right. So I can go ahead and multiply my 1/2 times my equation. And so I'm going to get x plus 4 times x squared plus 4x plus 3 to the negative 1/2. And remember, we don't like having negative power, so I'm going to move that power down to the bottom of my fraction. So I'm going to have my answer is x plus 4. Well, I'm sorry, not x plus 4, x plus 2. 1/2 of 4 is 2. Times x squared plus 4x plus 3. And instead of the negative 1/2, when I move it to the bottom, it becomes the positive 1/2. So that is my derivative using the square root. All right, so that's the chain rule using both an integer power and a rational power. So I hope this helps. So I hope you're happy, hope you're healthy, and I hope you all have a great day.